Hello, I'm James Flaten with the Minnesota Space Grant, and I would like to introduce you to the PTERODACTYL flight computer. The PTERODACTYL is a sensor suite with a microcontroller, and they're all mounted on a printed circuit board, which measures about 10 centimeters by 10 centimeters. PTERODACTYL is spelled PTERODACTYL. It's an acronym that stands for Payload to Enable Recording of Data and Communication Telemetry while lofted. The PTERODACTYL has some basic sensors which are useful for stratospheric ballooning, as well as a GPS, so it can tag the data that is collected with exactly where the device was located at that time. The basic sensors are pressure, 2 temperature sensors, and then a 9 degree of freedom inertial measurement unit, also called an IMU. So the inertial measurement unit measures 3-axis tip, 3-axis rotation, and also 3-axis magnetic field. Let's take a look at the device on a different camera so I can zoom in on it a little bit. And talk through its functionality as we go. Okay, so right here is the teensy microcontroller. So the teensy microcontroller has a USB port at this end for programming it, has an SD card here, which can be removed. So the idea is that's where we will log the data. And then as I work my way around, here's a pressure sensor. Here is the 9 degree of freedom IMU, which is all in that little chip right there. And then here is the GPS unit. So the GPS can be used to tag the data, so it's better, it's more easily understood. It also has some user-friendly things, including a tiny screen right here that's called an OLED screen. I'll turn that on in a moment. And then some flashing lights and also some switches which allow the user to set things about the device without necessarily having to plug it into a computer. In the middle, it has an XB radio. So the XB radio here allows it to talk to other units that have XB radios, such as other PTERODACTYL units, or perhaps a vent, or perhaps a cut-down unit, or perhaps an iridium unit that might be able to even talk to the ground. And then along here are a whole bunch of terminal blocks which allow additional sensors to be added to the device. This particular device is typically powered either with a 9-volt battery, which plugs in here in this jack, or this one even has a cable which allows you to power it with a 3.7-volt battery. And it has 2 thermometers. One of them is on the board down in here, and one of them is off the board at the end of this cable. So the temperature both of the device itself and also the temperature at some other location, perhaps within your payload or quite possibly outside of your payload. I have the parts for building one of these things, and so let me just show you, first of all, the printed circuit board. So here's the printed circuit board without any parts on it yet. Okay, so again, the teensy is going to go right here. This is the microcontroller, and then here will be a set of LEDs. Here will be the pressure sensor. It's an MS5611 pressure sensor. Here is the LSM 9DS1. 9 degree of freedom IMU. Over here is where the GPS will go, and it turns out that this thing is set to either use a U-Blox M8N or M9N GPS. So there's several places to plug in, but you'll only use one of them at a time. And then this is the XB radio right in the middle. Over here is where the 9-volt battery plug would go. And then all along here are places to plug in additional things. The most important part of it, of course, is the teensy. And so this is a teensy 4.1. This is the end where you would plug in the USB cable so as to program it and also to power it if you happen to be plugged into a computer. And then at this end would be where to put your micro SD card. Now let's look at the other parts. This can be assembled with exclusively through-hole soldering. So here are all the parts. back out a little tiny bit here. Okay, so we have the printed circuit board, custom printed circuit board. There's the pressure sensor. There's the OLED screen. Over here are the two thermometers with the comparison resistors, which don't change much with temperature. And then these thermistors do change. They're resistors that change with temperature. And so one of them will be on the board and one of them will be at the end of this cable, so I can measure the temperature at some other location. Here I have some switches for setting the mode of the device. There's the 9° of freedom IMU. There's the XB radio and the board on which it will sit. Here is a voltage regulator to change 9 volts down to 5 volts, and here's where to plug in 9 volts. Here is the XB module. This happens to be an M8M. Here I have 2 headers, which allow me to control 2 different servos. And then here I have additional headers, some male headers, some female headers, allowing us to put the boards on male headers and then put female headers on the printed circuit board itself. And the breakout boards will be on male headers and the TNC will be on male headers, so they can plug in and then be removed from the printed circuit board as need be. Over here are terminal blocks, many of which will go along the bottom, a few of which will go along the top to power or to provide power for other sensors. And then here are some standoffs, and the standoffs allow us to take breakout boards and attach them more firmly than just plugging them in. And the last thing, not least though, is the 4 LEDs, yellow, red, blue, green. Those will go right here, and those will flash, indicating what the device is doing at any given time. In fact, let's see the device as it boots up and understand a little bit of what it looks like when it's actually functioning. Okay, so here comes my state. Here's my pterodactyl. Zoom in on it. Focus on it at least. I'll plug in a 9-volt battery. For a balloon flight, I would use a lithium 9-volt battery. I don't happen to have one around, so I'm using an alkali 9-volt battery. And it didn't turn on, and the reason is it has a switch. So the switch is right here next to the 9-volt battery, and this switch will tell it, okay, we're going to use 9-volt power right now. Okay, so now the OLED is on. The lights are starting to flash. And right now it's actually waiting for some feedback about what mode do you want to be in. Now, it turns out that that light is so bright on the camera, I'm going to cover up those LEDs with a piece of tape in hopes that you can see a little bit better. Turns out that it has a hard time, this particular camera has a hard time focusing on luminous text. So right now it says XB mode, relay is on or off, receiving is on or off, and then press B. So it just wants me to press a button to go on. And so let me continue. XB setup, it's getting the radio ready to go, XB receiver. And now it's actually displaying some text. So I zoom in on that a little bit, see if I can get it so we can read that text. Here we go. Luminous text, a little hard to read. Okay, take my word for it. It says 000 feet. That just means that it's trying to give me GPS information, but it has no GPS line because I'm indoors. And then the next thing down says 66F, that's the internal temperature, and then external 63F. Okay, so it has 2 temperature values, and then it says 14.06 PSI. So in other words, that's the pressure number. Now, right now, the external temperature, which is at the end of this cable here, okay, so I'll just bring it in view. This is the external temperature, and if I were to touch that, I can actually make the external number go up. So 71, 73, 74, 75, okay, 76. So in other words, it's sensing the fact that something warm, my fingers, were close to that external thermometer. Now the internal thermometer is actually here. It's almost underneath the TNC. So what I'm going to do is I'm going to touch that with my fingers, And then I'll notice the internal number went from 68 to 69, 72, 74. Well, in other words, by touching either the external thermistor or the internal thermistor, I can make the numbers on the screen change. Okay. So I'm going to turn off my pterodactyl, unplug it. And just to recap, okay? So basically, we're going to put the pterodactyl on our flights. This will monitor the vehicle performance, as in whether it's tipped, whether it's spinning. We'll set the GPS into airborne mode to make sure that it will work into the stratospheric altitudes. In fact, we'll do the highest precision that this GPS is able to record, allowing us to hopefully see things like gravitational waves during an eclipse, gravity waves. And then the radio may well be used either to control vents or to fire cut downs or to talk to an iridium unit, which then can talk to the ground. And different teams may choose to put custom sensors on, like Geiger counters can be run by pterodactyl units. Various kinds of light detectors can be run by pterodactyl units. And one nice thing about this particular unit is that it's only through hole soldering, so you can actually put it together relatively easily. That's it, the pterodactyl.